Hi everyone, I'm Miss Felicia from the Bukit Timah outlet of OVERMUGGED. Okay, so for today I'll be going through review certain topics in the open-ended in the end of year exam. Because of the time constraint, I won't be able to go through like every single topic. Yeah, so I'll pick out like the more difficult topics to do. So for the remaining questions that is in today's worksheet, there will be answer key provided at the end of the lesson. Yeah, so then you can actually download it later when I show you. Then you can actually continue to practice it. Yeah, then you do it at your own time. Okay, so this was actually the previous round of the end of year revision that took place like 2 weeks ago. I don't know whether like did you all attend it. So back then we had like a range of subjects. Yeah, like what languages, sciences, math. Yeah, we have it. Yep. So just to share a little bit with you about Overmark. So Overmark is actually a team of very young and vibrant teachers. As you can see, yeah, we are not the old folks kind. Yeah, mainly it's because like so that we can like click with your and that although we are young, but it doesn't mean that we are inexperienced. So all of us are actually uni grads with at least like 5 to 13 years of teaching experience. So for Overmark here, we actually teach O levels, IP and A level. That's why I'm teaching your right IP students. Yep. So for Overmark, we actually have 3 centers. So right now I'm teaching at Bukit Timah. So for this outlet that I'm right now here at King Albert Park, it will be only for academic year 2023. So for 2024, we'll be actually shifting to Tan Kah Kee Station. I think it's a bit nearer because it's nearer to Botanic Garden interchange. Yep. And that next is that we also have another center at Parkway Center if you stay like in the east. Yeah, then we also have another outlet at like Serangoon Central. I think that will be more convenient for like the RI and RGS students. Okay, so then besides our 3 tuition centers, we also do rent like other spaces to teach. Yeah, so we also do teach at like Toa Payoh, Jurong East, Woodlands, and then up and coming it will be Tampines next year. Yeah, so currently for IP classes, we mainly have it at this outlet, which is the Bukit Timah outlet. Yeah, but of course, if like in future, like if you all feel that like you need tuition, you want to find Overmark, then if you can pull a group of friends, sure, we can always open a class dedicated just for your school at the location of your preference and at the timing of your preference. So like right now, actually, for me, like next year, I actually have like Nanyang classes. I also have like RGS and RI classes also. Yeah, cause like if I have enough students, usually we will try to like be more exclusive just for that school, then can like better cater to the school syllabus. Okay, so then so this is my name. I'm Miss Felicia. So I teach O level, IP, Chem Biophysics, lower sec, upper sec. Yep, I teach all secondary levels. And that this so far my track records. Yeah, my students generally do very well. Yeah, with all the tips and tricks that I teach at tuition. Yep, and that I'm actually previously graduated from NTU degree in science. And that previously before I joined Overmark this year, last year I was actually at another tuition center called the Learning Lab. Yep, and that even before Learning Lab, I was teaching at another tuition center called Wasteland, and I also did like quite some other teaching and all. Yeah, so this is actually my students. Yeah, so in my classes sometimes if got time, then I will like do an experiment with them. So this was a we use like the red cabbage, yeah, to do like acid indicator kind of experiment to test like the pH. Yep. Then usually for Overmark, we are very welfare kind of like center. Yeah. So actually we do provide like you see like you all come for free lesson, we still provide you free snacks, free goodie bag. Yeah. Then usually for regular students here, we will like sometimes we will order like koi, we will order like pizza, KFC, McDonald's, ice cream. Yeah. Then over here we also have like the snack bar outside. Yeah. So for those of you who attended physically here, today, because you attend camp, I give you only camp. But if you want like this mini booklet of the notes for other subjects, like example, if you want like for math, physics, you can collect from me because it's still on my table here. Yeah, you want to collect for like math or you want to collect for like bio, you can go to the shelf outside to collect it after the lesson today. Then for those attending online, if you wish to collect a copy, sorry, I can't distribute soft copy. It's only distributed in hard copy. If you want, you can come to the Bukit Timah outlet of Overmark to come and self-collect it. You can collect any amount you want. You collect for your friends, your relative, your cousin, your siblings. I don't collect for everyone also can. But right now, we only left with Sec 3 stocks. Yeah, previously we were distributing like got Sec 2 and JC also, but now run out already. Okay, then so what will we be doing today? So we will be mainly I'll go through the key concept. So if you look at the worksheet that I have for today, it will be mainly like a few pages of summary, like 1 or 2 pages at max, to tell you the key concept that you need to know for exam. And then I will also let you know the common misconception when we do like certain questions later. Then for the difficult questions, I will guide you through on how to solve it later. And the question I chose is the kind that like Usually schools will test kind. So hopefully like it will be more similar to what you will be tested in your end of year exam. Yep, as well as we'll look at the commonly tested question in today's worksheet. Yeah, so let's make the most productive 1.5 hours ever now. Okay, so let me go to the printer to collect the worksheet for those who are physically present. Sorry, give me a short moment. Then for those online, make sure you download it, okay? Yep, so the lesson link, this worksheet link is in the Zoom chat. I keep spamming, yeah, because I think maybe those who came in earlier cannot see the in-front message. Yeah, so make sure you download and have a copy to write on. So we will need to do a lot of writings on it. So as per your request, acid and bases. Let's take a look at the acid bases. Where is it? Yeah, over here. So this is the super condensed form of the mini booklet. Yeah. Okay, so let's take a look at the chapter of acid bases here. So key point need to know like acids. Yeah, acids need to know that mainly it is able to produce H plus ions when you dissolve it in water. Yep. So usually for definition wise, you need to have three key points. Dissociate to produce H plus ions when dissolved in water. Then for base, take note that base don't dissociate because for base, it can actually be subdivided into two categories. So for base, you can divide it into base and alkali. Yeah, you can divide it into base again. Why? Because for base, it will be insoluble. That means they will be solid state. As compared to alkali, alkali is soluble. So it will be aqueous state. Yep, so in this case, so that means in other words, if you draw a Venn diagram, right, you'll be like this. So base is the big category. Inside base, there are still bases and alkali. Yep, so only if it's soluble, it's alkali, the rest are base. So what is exactly base? So base is mainly metal with oxygen, like example, calcium oxide, zinc oxide. So all these are base, metal oxide, as well as metal hydroxide. By the way, my teaching style is that whenever I write and highlight on the screen, you follow and write it down in your notes. Okay, so you can write it in the mini booklet or in the worksheet that you have. Okay, so right, so metal hydroxide would be something like maybe iron hydroxide. Yeah, so any metal with OH, that will be metal hydroxide. So that's base. Then acid, you should know it has H. Then alkali is soluble. So between the metal oxide and metal hydroxide, how do you know which are alkali? So alkali would be those that is in the SPCA oxide hydroxide. So what is SPCA? It's not the Animal Foundation place organization. It's more of SPCA refers to S for sodium, P for potassium, C for calcium, A for ammonium. So this is the form SPCA. So whenever you see these four names appear, right, you will take it that they are soluble. They can dissolve. So you put it under alkali. Then if it's not this four, you put it under base. So maybe, for example, if I say aluminium oxide, so aluminium oxide, it will be under base. If it is like iron oxide, and then iron oxide also under base. Because as long as not these four, you put it all under base. So that's why base, it will be the rest except SPCA. It will be all of them except SPCA. Yep, so what I have just mentioned is shown over here also. Alkali is soluble. That's why they mentioned here, soluble. Because it can dissolve. That's why it can dissociate in water to produce OH minus ions. And take note that it is strictly, it must be in water. So if it's in something else, it doesn't work. Okay, so then I think you all should also know that there are some properties of acid, such as like acid can be like sour, can conduct electricity and all, right? So now, for example, if I were to give you an example, if I were to say that maybe I have HCl powder, so if I have a HCl powder, I try to go and test electricity, or maybe I try to test litmus paper. Do you think it will show acidic properties or not? The answer is no, correct. It's not acidic because it is dry. Another question. if, I have no space, oops, I draw on top. If I were to have HCl powder now, still powder, but then I try to dissolve it in maybe ethanol, then in this case, I go and test electricity. I test litmus paper. Do you think, is it acidic? And the answer is no, very good, because it must be strictly in water, okay? Cannot be anything else. So this is ethanol. So this is still not acidic. Yeah? Okay, so then, yeah, so these are the things to take note of. That is very strict. It has to be water only. Okay, so then besides acid bases, usually there comes salt, right? Yeah, so how do you distinguish between acid, base, and salt? So you need to know how to distinguish. If not, later they give you an equation, right? What calcium, carbonate, add this, add that. They need to know what they are, ma. So how do you identify them? Okay, so I'm going to use a blank page. So just to check, you're done noting now? If not done, maybe you want to take a photo or a screenshot. I'm moving on in 3 seconds. Then I'm going to clear the screen. So moving on, 3, 2, 1. Okay, moving on. Okay, so how do you decide if it's acid, base, alkali, or salt? When the question I give you like some like chemical name. Okay, so how do you distinguish? First, acid. Acid is easy. Okay, I mean I go by 1, 2, 3 lah. Then later you can tell me the answer. Okay, so if it's an acid, it's very easy because acid will have H in their formula. So maybe it's H something, and then that's acid. If it is a base versus alkali, how do you tell? So meaning that these two, they must be metal with oxygen or metal with hydroxide. Yeah, so it must be with metal and oxygen or metal with OH. Okay, so hydroxide is OH. Then next is how do you choose between these two? As mentioned just now, alkali must be SpCa. So base is don't have SpCa. Sodium, potassium, calcium, ammonium. Then lastly, it will be, if it doesn't fall under acid, base, or alkali, then it will be in the last category, which is called salt. So generally, salt is an ionic compound. So salt is usually made up of cation and anion. Okay, so maybe let me start to test y'all and see whether can y'all tell. So for those online, you can participate too by typing it in the Zoom chat. Yep, okay, so for the first one, if I give you this, can you tell me is it MCQ 1, 2, 3, or 4? So for those in class, can you point 2, 3, 4? Okay, very good. Most of y'all got it correct. The answer is acid. Very good. Then next, if the H I change to Na, then now, what is it? Which category is it under? Can you point the finger again? A lot of uncertainty, I'm not sure. Okay, so those who point, yep, you are correct. The answer is salt. Why? Because there's a cation, Na, and there's a SO4, anion. So that's why cation, anion is a salt. Or else you go by this, you go by elimination. No more H, so not acid, right? Then is it oxide? This is not oxide, this is called sulfate. It's not oxide. Yeah, so sulfate is not oxide. So it's not base or alkali anymore. So if you eliminate acid, base, alkali, you're left with salt. So the answer is salt. Okay, then next one. If I now change the SO4, I change it to maybe CO3. Very common, right? You always add carbonate plus acid and all. So in this case, what do you think is it? Is it acid, base, alkali, or salt? Can you point? Which one is it? Like some of y'all not sure still. The answer is still salt. Why? This is called carbonate. So carbonate is that it's not oxide, not hydroxide. Okay, so oxide is strictly just like O, like example, NaO, something like that. So if I say NaO, this one is oxide. Okay? Yeah, but this one is with a C already. It's not called oxide anymore. It's called carbonate. So need to be able to distinguish it. Okay, so that's why this is cation and anion. Of course, Na is a plus, CO3 is 2 minus. Okay, so then next, this one I told you that it's definitely a metal oxide. But which one should I put it as? Base or alkali? Which one should I put it as? Answer is alkali. Because of S for sodium. S for sodium, okay? S for sodium, that's why it's alkali. Okay, how about this? This is like some might be one of your surname, Ko, K-O-H. So in this case, Ko, is it acid, base, or alkali, or salt? Ah, no one have answer. What about the rest of you? Yeah, the three of you correct. Yeah, the answer, yeah, correct. It's alkali. Yeah, because K is potassium. Then P for potassium. Can? That's why it's alkali. Okay, then next is I test one last one lah. Okay, so then next is if I were to ask you what is maybe this, then what do you think is the answer? Acid, base, alkali? Yeah, correct. I think acid you all can get it lah. Because acid got H plus mah. It is phosphoric acid. Okay? Oh, I think I haven't given an example of base. Let me just give an example of base. Maybe like that. This will be a base. Yeah, because for base, it would be a metal oxide or metal hydroxide. In this case, metal hydroxide, it will be a base because this is Fe, iron. Iron is not Sp, C, or A. Hmm. Okay, so yeah, hope you can better understand how to differentiate between them. Then next is in this topic, it's not in my notes because my notes limited space, because my worksheet already very thick already, so I cannot put too much information inside. There is also the equations, right? Like what acid plus base, acid plus metal and stuff. So that one, if you can't remember, I got shortcut tips to help you. So for example, if you talk about metal plus acid, how to remember what you produce? So metal plus acid, you can go by this mnemonic called mash things up. What is mash? Mash means that it is metal plus acid. You get salt plus H2. Yeah, so this is a way to remember. Mash. Okay, there's another one called cash. Money. Okay, cash. So what is cash? So it will be carbonate plus acid. You can get salt and the H, be careful, this time around is H2O. Then, of course, carbonate must, of course, form what gas? Carbonate. Carbonate will form carbon dioxide. Yeah, so that's how you can remember. Yeah, so these are the tips and tricks that usually we will, I don't think your school teacher will teach you, right? Yeah, it's like tips and tricks that we usually teach at tuition only. Yeah, so like cash. Still got some more. Bash. Like you bash people up. So what is bash? Bash, it will be for the base. So B for base plus A for acid. You will get salt plus water. So take note that most of the H are usually H2O. Only the metal is then hydrogen. This is the only case where it's hydrogen. Even if you look at the what base plus ammonium salt, that one is also water. It's always water. So take note that the only common product is salt, because salt is guaranteed have. Water is not guaranteed because there is scenarios where there is no water. Okay? Yeah, so salt is compulsory. This is the compulsory product. Yep, you find somewhere to write it down because it's not in the worksheet. Okay, so then the ammonia one, that one have to just study on your own. That one I don't have shortcut already, I see. Yeah, so the fourth one, I'll just write it down on top. So it's the base plus ammonium salt. Ammonium salt means that it is like NH4 something. So it can be NH4Cl, NH4 nitrate, NH4 carbonate, NH4 sulfate, NH4 anything. Yeah, so this will be the ammonium salt. By no space really. It will be salt. Okay, let me erase this. I think you have to be done copying, right? Since I already written this very long time ago. Yep, so this will be salt plus ammonia gas, cause got ammonium, and then plus water. Yep, so this is the fourth equation. Yeah, so total 4 of them. I go and take the worksheet from the printer. You continue copy. And the paper. Anyone need to borrow paper? You all have, right? Okay, so I think that you should be done copying by now. I shall change the screen. Okay, so back to the notes here. Yeah, so then next also need to know that you usually use words like strength, concentration, basicity to describe them. So for strength, take note that strength it will depend on the name of the substance. It means when you see HCl, right, confirm is strong. No matter you add a lot of water or add a little bit of water. If it's strong, it's forever strong. Okay, so it's like the material. Like example, you hear metal, metal is strong. You hear plastic, plastic is like weak. So the name decides. No matter how thick or thin, metal strong means strong. Even very thin like fork is still very strong. Yeah, but plastic is like it's just always weak. Okay, so then next it will be concentration. Concentration, you use the words like dilute, concentrated, right? So that's why concentration involve the amount of water. Yeah, so if you add more, then it's dilute, or add less, then it's concentrated. Then next is basicity. Wow, this thing is very confusing because the name basicity, right? But it's to describe acid only. So the thing is that why is it even called basicity? Is because basicity over here, what they are trying to say is the number of H plus ions produced. Yeah, so that means it is mono basic. Mono means one. That means it's produced one H plus. Di means two. Di basic means that it produced two H plus. Yeah, so that means basicity is telling you how acidic it is. Yeah, so just be careful. Okay, the name a bit confusing. Okay, so I shall move on. Oh yeah, then as mentioned over here, all of them you cannot change because if it's like HCl, confirm can only produce one H plus ma. Or like H2SO4 is confirm is 2H plus. Yeah, so that's why it's not possible for you to like change. Yeah, so that's why the only one that can be changed will be concentration because you can vary the amount of water you add. Okay, then next it will be oxides. How to study oxides? Don't study individually. You go by this way. You go by metal versus non-metal. Because for metals, you can subdivide into two, basic or amphoteric. So all the metals will be basic except the three of them, which is the, I call it as the Z, Z-A-P, Z. So only the Z is amphoteric. The rest of the metal combined with oxygen, right, they will always be basic. That means like if you check like the pH, yeah, it will be like alkali pH. Then for non-metal oxides, yeah, all of them will be acidic except these three, which is kind of common sense because like, water, of course, is pH neutral, right? That's why water don't taste bitter like alkali. Water also don't taste like sour like acid. And then carbon monoxide and nitrogen monoxide, this one you try your best to remember. Yeah, so they are also neutral. Okay, then next is need to know what does the four words mean. I think you all should know, right? Basic means react with acid law. Then acid means react with base. Amphoteric means it has dual personality. Sometimes it can be acid, sometimes it can be base. So you can react with both acid and bases. Neutral is like example, I ask you, where do you want to go and eat later after the lesson today? Then you're like, I neutral, anything. Then the thing is that if you say anything neutral, that means by right, whatever food I choose, by right, your opinion won't count into it, right? So that means whatever food I decide eventually, it will be not related to you. Yeah, it's not affected to you, yeah, because you won't react or you won't like participate in the decision making of where the dinner place will be. Yeah, so that's why neutral means like they won't even react, like they don't even participate in the like discussion of the dinner place or like the chemical reaction. Okay, so for the question here, let's see which question should I get you to do? Let's do, I think we do the open-ended, but the MCQ I think you can do on your own. Anyways, the MCQ, I also have written down the like explanation. Yeah, so I'll actually write down all the explanation for every MCQ. So in case you get wrong, you still have the explanation for it. Okay, so for question number 5 over here, hydrogen halides are diatomic covalent molecules with the formula HX, where X is a halogen, which is the group 17 element. When dissolved in water, hydrogen halides, which is this HX, they will form an acid, something like HCl like that, the acid. Then there is this thing called pKa. So pKa is a number that measures the strength of an acid. Generally, the smaller the value, the stronger the acid. Because pKa is telling you the extent of like dissociation. Okay, then next is there's this thing called bond energy. What is this? So it's the energy required to break one mole of a particular type of bond. Something like, if H dash X, there's a covalent bond. So if you try to break the bond in between H and X, that energy or the bond energy, which is this energy here. Yep. So now they show you the values. So for part A, I'll leave it to you do on your own because it's just all 1 mark. Right? It's very simple question. You try on your own. I go through with you the more difficult one, like this kind, 3 marks. Okay, so part 4 over here, they ask you to state and explain the relationship between the bond energy Hx and the strength of the corresponding hydrohalic acid bond. Okay, so maybe let's take a look at the trend first. So what happened to the bond energy as compared to the strength? So generally, if it's a stronger acid, if we look at the earlier page, stronger acid, then they mention here, stronger acid, it should be smaller pKa value, right? So now, can you tell me how is the relationship? Is it like the bigger the bond energy, the stronger the acid, or is it opposite relationship? So is it directly proportional or is it opposite? Based on the way you read the question. So can you interpret now? Is it opposite or same? Opposite. Yes, correct. It will be opposite. Can you tell? Yeah, because over here, they mentioned that if you look at the number, as your number like increases, as your bond energy increases, what happened to your pKa value? Your pKa value also increases, right? Then what did they say? The pKa value is inversely related to the strength of the acid. That means the greater the pKa, the weaker the acid. Yeah, so that's why it's an inverse relationship. When bond energy increases, acidity is like weaker. Okay, so let's write that down as the answer over here for part 4. Okay, so state the relationship first. We do the state part first. So the higher the bond energy of Hx, I just copy the question. Can you see over here? Bond energy of Hx. Then continue, the weaker the acid is. Yep, so this is the first mark. So done with stating. Next, we need to move on to the explain part. Yep, so need to explain. So generally, what does it mean by higher bond energy? So let's explain that. So by referring to the front, bond energy is the amount of energy to break it. So if you have higher bond energy, means the amount of energy needed will be more, correct? So let's write that down first. So the amount of energy required to break will be more. Okay, so let me write it down. Wait, let me modify the front part. So we should say that a larger Hx bond energy means larger amount is required. Yep, then try to answer in context of the question. So besides just like just now I copy paste, do you realize I add on extra? So this time around I want to break what thing? This time around you're breaking the Hx bond, something like HCl, right? Yeah, so usually we will break this bond. Yep, so break all the Hx bond in 1 mole of what thing? 1 mole of Hx molecule. So I'm trying to answer in context of the question. Okay, then that's not all yet because it's 3 marks. Just one liner of explanation is not enough. Yep, so then next is we need to link it. So now we're done explaining bond energy, right? But I haven't answered about strength. So if it is like weaker, generally when we talk about weak acid, what's the definition of weak acid from notes? Partially correct. Yep, so that's what you should write. So hence the acid, you follow what your school say. If your school say ionize, you use ionize. Your school use dissociate, you use dissociate. Yep, so you ionize or dissociate to a smaller extent or partially. Done. So this will be the answer. Part B, the ionic equation. I thinking of going through ionic equation later because I actually got shortcut tips to teach you all, like on how to do it faster. So not all equation need to cancel spectator ions one. Got shortcut. Yeah, so later after I do the shortcut, then we come back here. Okay, so I shall move on. Should be done copying by now, right? So if you're not done, maybe you take a screenshot or a photo. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the next part over here, so they said that pH is a measure of the concentration of H plus ions in the solution. Hydrofluoric acid is a weak acid, while hydrochloric acid is a strong acid. So now they ask you to write an equation for this dissociation of the hydrofluoric, which is a weak acid. So how to write it? Do you all know how to write it? Maybe can you all try and write it out? Then I see your answers from your paper. Yeah, so can you write it in? Dissociation. Dissociation means how this molecule become dissociated. That means dissociate into H plus ions. So one of the answer is H plus aqueous. So that means what's hydrofluoric first? What's the chemical formula of hydrofluoric? Like hydrochloric like that, right? Hydrochloric is HCl. So hydrofluoric is, correct, HF. Then acid must be what state? You write it in. Then here, the arrow, you decide, is it single arrow or reversible arrow? So that depends on, is it strong or weak, right? So be careful in your arrow. Then acid always form H plus ion, right? And then what else? Yeah, so you write it in. So how? Oh, anyways, by the way, for those of you who are fast, yeah, you can actually do the other earlier question also if you want. So once you are done, then I will show the answer. We more or less done by now. I review the answer, okay? So the answer will be acid is always aqueous. Weak means you should use reversible arrow. Strong, you then use solid arrow. Okay, so strong, solid arrow. Weak, reversible arrow. Then H plus is always aqueous. And then fluorine, F minus, aqueous. Then just nice, the equation is already balanced. There's no need to do anything else already. Done. Okay. Okay, so I shall move on to the next part, part two. So part two, they said that state and explain whether it is possible for a solution of hydrofluoric acid to have the same pH as the hydrochloric acid. So in this case, what do you all feel? Do you think it's a yes or is it like a no? I give you a bit of hints. Soon you will learn it when you go to JC. Is that actually pH, right? There's in JC you need to calculate. So it's actually this formula, negative log, then a concentration of H plus. That means it depends on the concentration. So that means my hint to you is, do you think is it possible to make the same concentration of H plus for both hydrofluoric and hydrochloric acid when one is strong and one is weak? So what do you all think? Yes or no? Everybody unsure. Okay, so good that we go through this question today. Okay, so the answer is actually is a yes. The answer is a yes. Why? Okay, the reason is because, for example, right, if I talk about hydrofluoric, which is weak, so maybe like example, if maybe I got 10 HF, maybe only partially dissociate. So maybe only I have 5 H plus, for example. But then for hydrochloric acid, is like if I have like 10 HCl, all 10 will become H plus. Agree? So in order to make it like the same concentration, what I can do is here, because very little H plus, so maybe here I just put little bit of water. But then here is like a lot of H plus. Maybe I should add a lot of water. Because once I add a lot of water, the concentration get reduced. But here I put very little water. So although I only got 5, it became like more concentrated. So in the end, both sides, you can actually like balance out the concentration. Yeah, so that's why actually the answer is yes. It is possible to balance out the concentration of H plus ions. Can understand what I'm saying, right? Can okay, then let's write it in. So yes, because yeah. So in this case, for the weak acid, should it be concentrated or should it be diluted? You fill in the blank. You fill in the blank, dilute or concentrated. So these two blanks are the same. You tell me, is it concentrated or diluted? Yep, so these two pink color ones you fill in the box. Okay, so I shall review the answer now. So the first blank is, what is it? Concentrated. Can have the same concentration of what ions? Acid must always have H plus ions. Then this will be opposite, diluted. Done. So this will be the answer. Okay, so moving on to the next chapter, salts. Okay, so for salts, for solubility table over here, there are shortcuts that I will be sharing with you on how to remember. I don't know whether your teacher teach you all this kind of shortcut to study or just tell you, just go and study everything. Okay, so at tuition usually I find ways to help students easier to memorize things like just now the cache, bash, mash. So here I have actually this thing called I think the first one is quite, I think most schools should have taught SPAN. Yeah, so generally as long as it's span, SPAN, they will always be soluble. Okay, so span is always soluble. Always. Okay, then is the next few that is tougher to remember, right? So how to remember? Don't worry, it's not difficult. This one over here, chlorides. Chlorides, you go by, you wear cap when it's a hot day, or you wear cap to act cool. Yeah, so for cap, what does it mean? Cap means chlorides are usually soluble except Ag and Pb. And so all chlorides are always AQ. So chlorides are always AQ except these two. So if it's AgCl, it will be solid. PbCl, it will also be solid. Okay? Okay, then the next one, sulfates. Sulfates, how to remember? You go by, I no space. Okay, I write it on the right side bar. So sulfates, S for sulfates. Sulfates are always soluble. Soluble means they are AQ except the three sizes that you learn now. So what are the triple signs that we learn? Can you tell me? What are the three sizes that you learn? Yeah, correct. So we learn physics, we learn bio, we learn chem. So B for bio, B for BA. Then C for chem, C for CA. Then P for physics, P for PB. Yep, so all of them is just, you just go by BCP. Most of them is letter A or B lah. Can you see? It's BA, CA, PB. It's letter A's and B's lah, generally. Yep, so all sulfates are all aqueous state. Only these three, you then bracket S. Okay, because sulfates, S for sulfates, S for soluble. Then for carbonates, it will be the norm lah, I would say. The carbonate is the norm. That means usually it will be insoluble. So you can see that over here they write all. All are insoluble except spar, because spar or span, they will always be soluble. That's why if it's like sodium carbonate, potassium carbonate, ammonium carbonate, as long as it's spar, it will definitely be soluble. Yeah. Then phosphate only selected schools. So if your school never cover, then it's okay, you can skip that. Okay, so that's how you memorize the solubility table. So now I hope it's easier to remember it now that with all the tips and tricks. Okay, so I shall move on. If you're not done writing now, maybe you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so moving on to the next part over here for the salts. We always learn that there are mainly like titration, precipitation, add excess insoluble to acid. But the thing is that how do you decide when to choose which? So you cannot study individually. Because every time they give you a compound name, like example like barium nitrate, then how do you know which method to use? So then how to decide? You first check. So for example, if my answer is like barium nitrate, if that is my salt that I want you to obtain, so first you check, is it spar or not? That means does it have sodium, potassium, ammonium or not? I hope you remember by now. I keep using this, right? Even just now when we were doing about the alkali, we also use this word, right? SPA or SPCA. Yep. So you check inside, got any of these three or not? So now this one, don't have, right? Don't have means it's under non-SPA. So under non-SPA, you check, is it soluble or not with the solubility table on top? So just now I said N for nitrates. Nitrates is always soluble, right? So if it's soluble, you go to this side. Oh. That means to prepare barium nitrate, I should actually do this method. I should add excess insoluble to acid. Yeah, this is the method. Okay, then next is why. Why is it like the flow chart is like that? Okay, the rationale behind it is because whenever it is SPA, it's mentioned above that SPA is forever soluble, right? You see, don't even have any exception. So it is definitely soluble. That means my starting reactant must have either like SPA, that means my starting reactant are also soluble. Then my end salt, my end product is also soluble. That means starting is liquid, ending also liquid. That's why I can do titration. Because you all did titration in school, right? Where you had the pipette and the burette, everything are all liquid form. Yeah, that's why it's for soluble things. Yep, so that's why titration is for SPA, which is soluble. Okay, then next over here for non-SPA. Non-SPA is because you see, like now, nitrate, yeah, it is soluble. But the thing is that to make barium nitrate, it is usually barium something plus something nitrate. So if it's barium something, that barium something may not be soluble. So if it end up as barium something is a solid, I cannot do titration. That's why for non-SPA, you have to usually use things that is like might involve like some solid things forming. Yeah, so that's why like you cannot do titration anymore. Okay, so then for the non-SPA, if it's insoluble, obviously you should use precipitation because precipitation is where you form the solid one. You already said your salt is insoluble. This is your insoluble salt. That's why you should use precipitation. I need to know that precipitation is very iconic that they always have this equation. Equals get solid equals. If you can recognize this, right, later when I teach ionic equation, there will be shortcut for it. If you can recognize that precipitation is always equals get solid equals. Definitely one, the state symbols won't change. Okay, for precipitation is guaranteed true. Okay, so then in this case, Okay, so then next it will be for the next one here, the add excess insoluble. Just to share with you that actually, right, this and this, right, is all the acid basis equation. You know the cash bash mesh that I went through with you just now? Yeah, both are the cash bash mesh. Why? Because you see, acid plus metal. Metal confirm insoluble, right? So that's why in this case, we put it under here. It's insoluble. Then besides mesh, we have bash, right? B-A-S-H. So B is base. So base, if it's insoluble, you put it here. If the base is soluble, you put it under titration, because titration, pipette and burette must all be soluble form. Then the next one is cash, right? So the cash, you also check soluble or not. Insoluble, you put here, because here says insoluble. Soluble, you put it on the left side. So can you see these two actually combined together, they are all your acid basis reaction. Nothing new. Yeah, so that means in other words, these two reactions, you must have the acid. So one of the common misconception, right? Let's write it down. One of the common misconception that your friend might make it, so please don't make it now that I highlight to you. One of the common misconception is student, right? Like for example, like titration, they just take any two liquid. So if you take any two aqueous things are wrong. Because I told you already, it must be the acid basis equation. So that means the correct way is you must take acid plus something. It cannot be any two aqueous. Because you must follow the acid base equation. It must be acid plus something. Okay, so same for this insoluble part also. So this insoluble part, it must also have acid. So the add excess insoluble, this one, you also must have acid. So must have acid plus something. It's not you anyhow mix, okay? It's not anyhow mix then can get one. Must still follow the acid-base equation, which must have acid. Okay, then another misconception for students that is in the excess insoluble is sometimes instead of memorize, because sometimes exam, like study too much. Then after a while, oh no, I confused, I cannot remember. So like sometimes students might say that, oh, I add excess excess acid. Cannot. This one is strictly excess insoluble, not excess acid. There's a reason behind it also. It's not just, oh, because teacher say like that or note say like that, then you must memorize. No, no, no. you can understand it. How to understand it? So mainly is by, because if you have the salt, can you see that your salt is aqueous? Then insoluble is solid, right? Acid is aqueous, right? So now, for example, you add wrong. You memorize wrong. Maybe you memorize as excess acid. So you see, if your salt is aqueous, your acid also aqueous, how do you separate two liquid things? Two liquid mixed together, how you separate? It's like very difficult to separate, right? You know, separate can actually is like by fractional distillation, which is very tedious. You need to prepare what fractionating column, what the round bottom flask, Bunsen burner, and all is very tedious. So that's why we tend not to add excess acid because it's difficult to separate. Difficult to separate the aqueous acid and the aqueous salt. Yeah, two aqueous thing is very hard to separate. It's very hard to separate two liquids. That's why the excess one, it should be the insoluble one. Because if it's insoluble, it's easy to remove, right? As mentioned here, filtration, just take a filter funnel and put filter paper, done. Very easy. Yeah, it's like one hand I can even do the filtration. I just wait for it to drip. Yeah, so that's why we always add excess solid so that it's easier to remove. That's the reason. So why is it excess insoluble? Is so that it's easier to remove the solid. That's the science behind it. That's the reason behind it. Yeah, so now that you understand, I think it will be easier for you to remember also. Okay, then after you perform all these experiments, then of course, to obtain back your dry salt crystals, so for titration, they are all liquid form, then you do crystallization. Um, Although you can do evaporation to dryness, but usually we do crystallization and not evaporation to dryness. Do you know why? Both can get crystals, right? So I'm talking about any kind of substance. So any kind of substance, like why do crystallization? Why I don't do evaporation to dryness? Any idea? Like example, my BaNO3. Why I do crystallization? Why don't evaporation to dryness? This is not sugar, what? This is also not like what the things that will like you will decompose, right? So if things that doesn't decompose, why do I still do crystallization? Okay, the reason is because crystallization is known to have higher purity. So this is from the topic of separation techniques. Yeah, so for okay, so just to do a quick recap on separation techniques between the difference of evaporation to dryness versus crystallization. Okay, so if it's crystallization, no space, and then evaporation to dryness. Okay, so now I'm going to write out the advantage and disadvantage of each of them. So of course, crystallization, the advantage is that it is higher purity. So why we don't use evaporation to dryness? Because it's lower purity. How to memorize which one higher, which one lower? Usually teacher just at most stop at, you just can identify high or low. I think it's good enough. There is no need to like explain why is it more pure or why is it less pure. Okay, so how to remember? Usually my method of remembering is, this is just an analogy, it's not accurate, okay, in terms of like chemistry wise. So my way of remembering is, if you do evaporation to dryness, is that you stem the fire until like it totally dry. So that means like if I have any impurities, maybe a bit of sand or a bit of like I don't know what kind of bacteria or whatever thing, it might still be left in the bowl. So to me, my feeling of evaporation to dryness is like not very clean. Yeah, because there might be some residual other substances in there. But if you do crystallization is you heat until saturated. Then once your crystals form, you pour away the liquid. So in a way, I can pour away the impurities. So I will feel that like crystallization seems to be more clean. So that's my way of remembering that crystallization is cleaner, higher purity than evaporation to dryness. But this is not true. Okay, it's chemistry-wise, they won't ask you further. You just can state higher, lower purity, good enough. Okay, this is just my way of how I remember concepts. Okay, then of course, all things is like not perfect. If we have disadvantage, of course, it must have an advantage to compensate it, right? So evaporation is that it can be done very fast. Yeah, because you just spam the fire, just blast the Bunsen burner until it totally dry. And so maybe like 20 minutes settled. As compared to crystallization, it will be slower because once you reach saturated solution, then you have to put it on the table to cool down. Then after you cool down already, then the crystal then start to form. The crystal form already, then you then do filtration. So it's like, yeah, the whole process is like very slow lah. Yep, so crystallization is, if you got time, you should do crystallization because it's more pure. But no time is evaporation to dryness will be better if the substance don't decompose. Okay, then next part over here. Oh, sorry for the arrow. I think the arrow fly down from somewhere. Okay, so next is whether need accuracy or not. I think you all know, right? Titration of course need the accuracy, right? Drop by drop. The rest don't need accuracy. Because precipitation is you just take 2 cups of aqueous, you just boom, mix together, then you form the solid, can now. Yep. So even if you got excess aqueous, never mind. Because what I want is the solid. So what I want is the residue. So any excess filtrate, I'll just pour it away. So it's okay to have excess. This one, the name already suggests excess. So definitely don't need accuracy. I shall move on. I think that you should be done copying the table. If not, you take a screenshot. I'm moving it on in 3 seconds. Okay, so moving on. Okay, then the next part over here for the test for cation ions. So it's like the table in school is like, wow, like very long, right? Like how to remember everything. Okay, so here got method to help you to remember again. Okay, so generally how you remember is you go by amphoteric. Just now I went through with you, right? Amphoteric is the ZAP. Yeah, so generally ZAP they will be soluble in excess because of their dual personality. Like at the start, when you add a bit of NaOH, okay, I react with you, I form the precipitate. But later, if you spam and add in excess, it changes its identity. Oh. So instead of forming precipitate, now I change my identity, then I become soluble. Because once you change the identity, the solubility changes. That's why for amphoteric, they can change their observation. As compared to the rest, you see, like even the transition metals or like calcium, all these are not amphoteric. They only have one result because they don't have dual personality. They can't change their observation. Yeah, so that's why the observation will be the same. So that's how you can remember. Then if you were to let it react with aqueous ammonia, which is a weak alkali, then in the end, Al and Pb will end up having the same result. So if Al and Pb end up having the same result, do you know how to differentiate them? What can you add to differentiate them? Do you all know? No one knows? Okay, good that you are here. We do revision now. Yep, so to further differentiate them, you can actually add Ki or any chlorides. The reason is because if you add in chloride or iodide, as long as they are the same group, right, they will have the same chemical properties. Hence from the chapter of periodic table. Same group equals to same chemical properties. Yep, so that's why once you add like anybody from group 7 to PB will always form an insoluble precipitate. Cause remember in the solubility table just now? So just now I was teaching you the cap, right? CAP, the where cap, the cap. Yeah, so chloride is take note that lead chloride is insoluble. Yeah, so that's why mainly is usually to test whether is it present or not. We mainly want to form precipitate ma. Yeah, so that's why over here you try to make precipitate. Oh. So since you know that lead and chloride is insoluble, you try to create lead chloride. Ah. Or you want lead iodide also can because same group, they will also same chemical properties, means they will also form the same thing, which is a precipitate. Then generally chlorides will be white PPT, then iodides will be yellow PPT. Because based on what you learn in the periodic table, group 17, down the group 17 halogens will get darker and darker and darker. That's why chlorine on top is white. Iodine below a bit darker. So that's why darker version of white, yellow. Okay, then next thing to take note is that all of these hydroxides, right? Like example, I say that, oh, I see like white precipitate, I see like what blue precipitate, all these precipitate, you need to know that all the precipitates are all metal hydroxides. Okay, so take note, all the precipitate, right? All precipitates are all metal hydroxide. That means if you form like maybe a blue precipitate when you put copper, but the answer of the precipitate is called copper hydroxide. If you're testing for the presence of zinc, then you got white precipitate. So the white precipitate is zinc hydroxide. So it's always that metal and hydroxide. Hydroxide is OH. Okay, then take note that only transition metals have like very nice colors. Non-transition metals, they will always be either, okay, so let me write it down, non-transition metals. Can you copy this down too? So non-transition metals usually is that if they are PPT, precipitate, they will usually be white color. If they are a solution, so solution, it will usually be colorless. Only transition metals then can have color. So usually we will say non-transition metals are no color lah. So no color means white for solid, colorless for liquid. Okay, so then next is how to remember. For copper, I think should be okay because copper is like, you all did, I think most of your schools did the practical experiment of making the copper sulfate crystals, the crystallization at the start of the year. Most schools should have done it. So the blue color crystals is copper, that's why copper hydroxide. Yep, then for iron, how to remember? You go by this. Because iron, right, this is iron 2 plus, Fe 2 plus, right? This is Fe 3 plus. So from, usually for the charge is like, usually an atom, you lose electron one by one. So you lose 1 is 1 plus. You lose 2, 2 plus. You lose the third one, become 3 plus. So usually it's stage by stage. So usually Fe 2 plus happen first, then Fe 3 plus happen next after. So the thing is that iron, you can think of rusting. Yeah, so actually rust is actually made out of Fe3 plus. So rust usually takes time, right? Yeah, so if you need time, that's why it should be the behind stage. That's why the Fe3 plus is the rusty color, which is the reddish brown. Then for the previous one, it will be dirty green instead. So in case you get confused between Fe2 plus and Fe3 plus their color, just remember, rusting takes quite a while to rust. That's why it should be the later stage color. So it should be the 3 plus color, not the 2 plus color for reddish brown. Okay, so I shall move on. I take it that should be done by now. Okay, then next is for the test for anion. Let me highlight to you one of the common misconception that students have. So one of the common misconception about students is they see this. They see that, you add like what, NaOH, then they got pungent NH3, right? Then they tell me that this test, right? They tell me that this one is to test for ammonium ion. Then wrong now. Because they see that ammonia gas what? Ammonia gas means that got ammonium ion. Not true, This is not to test for ammonium ion. We have to read carefully. If it's NaOH plus aluminium foil plus warm, this one is not test for cation. Because if you compare, right, test for cation versus this one, versus this, test for cation is you only add NaOH, correct? You only add NaOH, only. But if you add NaOH already, right, you still go and add in extra stuff like aluminium and warming, right? Is from a test for cation, now it becomes test for anion instead. So take note, these two tests are very close. Both use NaOH, but here got extra aluminium foil and warm. So one is aluminium foil and warm is to test for nitrate, not to test for what ammonium or to test for cation. No. Okay, so don't just see ammonia gas and every time choose ammonium. Because usually teacher MCQ option, they like to put ammonium ion. Because a lot of students see ammonia gas, they choose ammonium ion. Just be careful, think twice. Think twice. Usually this kind of question is a trick question. Yeah. Okay, then next is again same thing. This whole table, usually in school, teacher just ask you, okay, go and memorize it, right? But how to make it easier? There's so many words again. Like there's so many things to memorize. So how to remember it? So here's the tips to remember it. So mainly is in order to prove that they are present, you can see from the test for cation page is to make sure that you form PPT Because once you have precipitate means yes, I know that it is present. So that means over here you do same thing also. You try to make precipitate. That means over here, your aim is for the test for anion is, your aim is to make insoluble precipitate. So that means what you can do is, you just use your solubility table. Solubility table very easy to remember, right? Because I teach you all the shortcut what S for sulfate, S for like soluble except sciences, then what cap and all. Yep, so you use the solubility table. If you want to form sulfate, what thing is insoluble? So remember, S for sulfate, S for soluble, except the three sizes that are exception, right? So the three sizes that are exception will be bio, chem, physics. Add letter A's and B's. Yep, so in this case, that means what you should be adding is I should add something that can form solid because these three can form solid. So that means I should add Ba something, because I add Ba, right, with sulfate, I can form solid. Or you want to add Ca also can. So it's just that textbook usually they write Ba lah, but add Ca also works, okay? Ca works also. So calcium something also can, because calcium something will form calcium sulfate. Then you have your precipitate. Usually we tend not to choose Pb. The reason is because besides PbSO4 that is insoluble, there's another insoluble lead. PbCl2. Remember the cap, the C for chlorides? Yep, then P is Pb. So the thing is that if you were to form solid when you add lead something, right? Then the thing is that how do you know what is present? Is it lead sulfate that form your precipitate? Or is it lead chloride that form your precipitate? Yeah, because lead is like capable of forming solid things. So you can't tell which anion it is, especially when you are testing for anion. That's why we tend not to add lead, because ambiguous. You can't tell is it sulfate or chloride. So best is you add something that is more unique. So Ba is the most unique lah. Yeah, you add Ca also can lah. But usually we add something that's more unique. Okay, so that's why Ba or Ca works. But textbook write Ba. For the next one, also same thing. To test for the presence of chloride ion, also the aim is to make insoluble solid. So based on the mnemonic cap, is that chlorides usually are soluble except Ag and Pb. And again, same thing. I told you, don't use Pb liao because it's very ambiguous. Can mean that sulfate or chloride. So I don't know which one present. So since cannot use Pb, you use Ag. That's why it's Ag something. Yeah, so that means sometimes, right, experiment, right, worksheet question, they may not add HNO3 and AgNO3. They can also change to like what, maybe H2SO4 and AgSO4 also can. Yeah, so as long as your acid and your behind match, same, then can lah. So it's mainly the in front that matters. Okay, so sometimes question, if they change to like sulfuric acid and silver sulfate, still can test, okay? So take note, teacher can change the question, can tweak the question a little bit. So the main aim is whether can form insoluble solid or not. Yeah, so if chlorides are soluble, same group means same chemical properties, means iodide also insoluble. So this will be the answer. That's why they showed you over here. Like if you want to use lead also can, but I won't recommend because lead is ambiguous. So yeah, they wrote lead also, but better not. Okay, so yeah, that's how you remember. The top one I think is very easy. Top one is how to test for carbonate, the carbon dioxide testing. Just acid plus carbonate, you can get carbon dioxide now. Then use lime water. So the first one is easy lah. Then done. That's all for the notes here. Okay, let's try out the question from this topic. Okay, so can you try question number one? Question number one is difficult. Yeah, so I'm going through all the difficult one with you. The easy one you do at home. You try question one now, but if you can't do, it's okay. You try. For those online, if you manage to come up with an answer, maybe do you want to like let me know in the Zoom chat what is your answer? Then I can tell you whether like are you on the right track or not. So how for those present here, what are your answers? No. But it's okay because it's meant to be difficult lah, so it's normal to get it wrong. Not D, not D. A, not A. Don't tell me like the physics class. No, not B, C. The physics, the physics class also. We have one question, you guess everything, then in the end only have something correct. Okay, the answer is C. Okay, so why is the answer C? Okay, let me explain. That's why I want to go through, right? Because it's difficult one. Okay, so normally I think you all know of electrical conductivity in the topic of acid bases. Usually like that, right? Do you agree? Usually you reach until zero from like normal questions that you do. So why does it reach until zero? This one is usually for neutralization reaction. Because for neutralization, if example, maybe at the start, maybe I have a lot of acid. Then if I keep on add a lot of OH until when it's exactly equal number, then it will form H2O, isn't it? Then H2O is like covalent. Simple covalent don't conduct electricity, right? Yeah, so that's why the conductivity will be zero. So usually at this point is the so-called equivalence point, also called the end point. Oh yeah, by the way, talking about this, let me just also go through it with you all. Do you all know that there is a difference between equivalence point and end point? It's not supposed to anyhow interchange to use. Okay, so what's the difference? Okay, so equivalence point usually is a word that we use in theory, while end point is a word that you use in practical. For example, if you do titration, you cannot add until suddenly there is a color change. So that is called end point because it marks the end of your experiment. Once your color change, okay, you end your experiment. Can you go and read your burette reading now? So that's why endpoint is for practical. So this is usually involving color change. As compared to equivalence point, as the name suggests, it has the word EQU. EQU meaning it has equal, what thing? Equal number of like H plus and OH minus. Yeah, so this one is usually in theory. Like example, you do mole concept calculation, and then you calculate to see like a number or mole of H plus equals number or mole of OH minus. Yeah, so that's why equivalence point is where you can calculate is equal number of ions. Okay, so that's why it's more for theory because it's calculation. Okay, so in this case over here, why did I say it's equivalence point is when you got equal number, you only have H2O. You don't have any spare H plus or OH minus to act as the mobile charge carriers or to like carry your electrical charges. Yeah, so that's why usually if neutralization, it should be like that. That's why based on the over here, remember I was testing you how to differentiate between acid, base, alkali, salt. So I think now you should be able to tell that D is actually neutralization reaction. Yeah, because D, can you see this is a sodium hydroxide? It's a metal hydroxide. Whenever it's a metal hydroxide, and then this is the SPCA, right? S for sodium, metal hydroxide. This will be alkali. So this is an alkali plus acid. So this is actually the neutralization reaction. So if you choose D, your graph needs to reach all the way to the bottom like the way that I've drawn. Okay, so then for this question, so why is the answer C? Is because if you notice the electrical conductivity, there's still some electrical conductivity. It didn't reach all the way to zero. So it still has some form of electrical conductivity. It must mean that it have something that is aqueous. Because based on your topic of acid chemical bonding, you'll learn that whenever it's ionic in the aqueous state, it can conduct electricity, right? Yep, so that means in this case, if you want to have something ionic, remember when I was testing you between like how to differentiate between acid, base, alkali, salt, I mentioned to you that ionic is usually salt, correct? Because salt is usually cation and anion combined together. So that means best is you have a salt, a cation and anion combined together in the aqueous state. Yep, so that means in other words, your originally it is like aqueous. Then suddenly you realize, oh, less and less electrical conductivity, but still got aqueous. So that means this experiment is trying to say that at the start, if you highlight the question, they say that it's solution T and solution U. Based on this statement, I know that at the beginning, I have two things that are aqueous, correct? Because both are solution. Then next, what am I forming? So I realized that I need to at least still form something aqueous so that I can have a ionic salt to conduct electricity. But of course, when my electrical conductivity decreases, like over here, it means that one of the aqueous actually disappeared. Correct? Because if it still remain as 2 aqueous, it should be a straight line, because 2 aqueous form 2 aqueous should be straight line. So this coming down meant that one of them actually became solid. Then solid don't have mobile ions, then cannot move, so cannot carry charges, cannot conduct electricity. Yeah, so that's why this part is saying that solid is formed. So that means now we are asking you what is T and U. So you have to check that T and U must be first, both are aqueous. So let's double check the options. You're done copying everything, right? If you're not done, maybe you want to take a photo. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so over here, you must make sure that both of them are aqueous. Okay, so now you check your solubility table. Which one can we eliminate? We already eliminated D, right? Just check for the rest. So which one can we eliminate? Which one got solid? We need to cancel the solid. Which one is solid? A, correct. Barium sulfate is solid, There's one more solid. Which one can we cancel? Which one is solid? You check your solubility table. Again? Correct. Calcium carbonate is also solid, Cancel. Then done already, only left with C. Can? So these two aqueous. So this is actually precipitation reaction. Remember I told you, precipitation is aqueous, aqueous. You can get solid aqueous. You give it a try, You just swap the partners. Make a silver with chloride. And then you have magnesium with nitrate. Yep, so then now you check the solubility table. Silver chloride is solid, and then SCAN. Nitrates are always soluble. Yep, so yeah, this is the precipitation. Then it match what? Then you have one of them solid, and then still got the aqueous to help you to conduct electricity. Okay, so this accounts for the decrease in conductivity. This one is to help you to conduct electricity still. You can still conduct electricity. That's why the conductivity didn't reach 0. Yeah, like that. Okay, so question number 2, I leave it to you to try it out on your own because not difficult. I move on to question number 3. Okay, so this one we'll just go through the main gist. The writing, I'll leave it to you right on your own. Okay, so question number 3, they said that use the following information to suggest the steps needed to prepare by precipitation of pure dry barium sulfate using aqueous iron 2 sulfate and powdered barium carbonate. Okay, so first, if they want you to prepare barium sulfate, so first, can you look at the flow chart? You know, there's some of the what spa and non-spa, the flow chart, the salts flow chart. Can you refer back to the notes? So for barium nitrate, which method do you think we should use? Oh wait, I think the question actually told you the answer. The answer is precipitation. Okay, so anyways, without them telling you, I think you can figure out also, because for here, yep, so because for barium, the question is barium sulfate, right? So for barium sulfate, barium don't have spa, it's B one, it's not SPA. Then next is barium sulfate, you check the solubility. Barium sulfate is here, it is insoluble. So that's why you go to insoluble. The answer is precipitation reaction. So precipitation is, you must start off with aqueous, So now let's check, is your starting 2 items, they give you aqueous or not? So the starting 2, what did they give? They gave you this aqueous. Oh, very good. This one, oh no, it's not aqueous. That means the first step is you must make this to become aqueous. So how to become aqueous? So that means now we need to convert barium carbonate to aqueous. So do you all have any idea like what can we add in to make it to become aqueous? So what actually do we need? We need barium. So barium very important. So you can add something that get rid of the carbonate so that it can become aqueous. So that means now the aqueous thing, it needs to be barium something. And then must be aqueous. And then next is we also need sulfate. Very good. Here got sulfate now. Settled. Okay, so now barium what thing can be aqueous? You can check your solubility table. Barium what thing? So this is cation. That means the other one should be anion, right? Again, louder, hang on. What? Nitrate. Yes, correct. Very good. Because all nitrates are soluble, right? The SPAN. Span. Span is always soluble. Just choose nitrate. Confirm soluble one. Yep. So that's why now we need to make it to become barium nitrate. So now, what kind of reaction is this? This is a barium carbonate. What can you add to become barium nitrate? So this is carbonate, right? Carbonate will react with acid. So which acid should we add? Nitric acid, oh. Can? Then now, how to write the steps? In the chapter of salts, in the textbook, there's a lot of steps, right? Like in your school notes also. There's one whole, I think you all know which part in your school notes, right? There's like step 1, 2, 3, 4, 5, 6, 7 for like precipitation, add excess, titration. So now, out of the 3 pages, which one do you think we should copy from? Because it's steps, right? So now I give you a hint. This one is powdered, right? Solid. This one is acid, right? So out of the 3 methods, which one should we copy for the first part here, this equation here? Should you copy titration, precipitation, or add excess? Add excess, correct, very good. Because based on the page of add excess, over here, add excess insoluble. This is the insoluble, right? So you add excess insoluble barium carbonate to acid, nitric acid. So actually what you need to do now is you just copy from your school notes the steps, the step 1, 2, 3, 4, 5 for the add excess one. Okay, so let's write it down. So in your answer, the first one, it should be you copy down the add excess insoluble. So you copy down the steps from the notes. Copy from notes. Okay, then after you're done already, then yay, we finally got our aqueous already, right? That's the aim. Then our aim is to get the aqueous. So yeah, now I have this aqueous. Then I will react with the aqueous. So now which step should we copy out of the 3 steps again? Precipitation, no? Because the aim is to perform precipitation, right? So that's why step 2, it will be you copy the precipitation steps from the notes. Yeah, like that also this will be the answer. So I leave it to you to copy from your notes. Just remember to answer in context. Like need to put the words like barium, carbonate, nitric acid. Just put it inside to answer in context. Okay, then the last one that I wanted to go through with you is ionic equation, because they're short, but to save time in exam. Okay, so I shall clear the screen. Should be done popping by now. If you're not done, you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so let's go to the ionic equation. So for ionic equation over here, key points to take note is that must have 6 symbols, and then make sure you must count, make sure the numbers are balanced. Yep, then only ionic equation got charges. So normal chemical equation should not have any charge. Okay. Then next is take note that if you can recognize neutralization reaction and precipitation, right? These 2 are the ones that got shortcut. For neutralization, I think quite easy because the acid and alkaline kind of reaction. Yeah, it's the precipitation they need to recognize also. Precipitation, I told you, right, is the aqueous plus aqueous, you get solid aqueous. Okay, so in this case, let me go through neutralization first. So for neutralization, take note that for the shortcut to work, right, it's not any acid, any base. It has to be aqueous form. Because if it's not aqueous, then the shortcut doesn't work. Okay, so the shortcut is for aqueous acid and aqueous alkali. So can you highlight it? Must be aqueous. So whenever it's any aqueous acid and aqueous alkali, don't need to do cancer spectator. Just write this in. Confirm the answer correct. Be it like monobasic, dibasic, tribasic acid. That means no matter how many H the acid have, right, the answer is always the same. Don't need to think, write it, move on to the next question. Can guarantee true. You don't believe, you can try it out, like hydrochloric acid and calcium hydroxide. You go home, you try to write out, then cancer spectator. You realize the answer is still the same. Okay? So whenever you see like that, both are aqueous, just write this as answer. Done. Shortcut. Okay? Then the next one, it would be the precipitation reaction, also got shortcut. So for precipitation reaction, first you have to find out what is your precipitate. Because the name already suggests the main thing is precipitate. So what's your precipitate? So maybe just now ours was about barium carbonate, right? So for example, if it's barium carbonate is the precipitate, what you do is you start writing the insoluble product first. So I write this. Then you work backwards. So I work backwards. So barium carbonate is made out of barium and carbonate. Correct? Then since this is an ionic equation, means you must change it to ions. So check periodic table. Barium is Ba2+. Then carbonate is CO3 2-. Then remember I was saying that precipitation starting one must always be equals, right? Can you see your starting reactant? Starting reactant must always be equals. So confirm state symbol is equals. And anyways, when you do the cancel spectator ion method, you also learn that is equals, then you write the ion form. If it's solid, liquid, gas, there's no need to break it into ions. Okay? Yeah, then done already, shortcut. So you see, you don't even, it's like one step, you can do it very fast some more. But of course, you must check like, is it balanced or not? Because like maybe if I, example, instead of BA, right, maybe I change it to like NA, right? Then you need to add in coefficients lah. Like if it's NA, then you must put the 2 in front lor. You must make sure the numbers still balance lah. So the normal chemical equation balancing thing still applies for ionic equation. You see, fast, right? Like that. Then if it's not like neutralization, not precipitation, then no choice lor. You have to okay, so this is just showing you lah. Like if it's copper carbonate, you just shortcut lah. Just copper plus carbonate lor. So if it's all other chemical reaction, then sorry, don't have shortcut. You really need to do what your school have taught you lah. Right now, everything that is aqueous, you break them into ions. Solid, liquid, gas, don't need to change. Only change the aqueous ones to ions. Then those that is exactly the same, you cancel out. Then whatever that is left, that will be your ionic equation. Okay, so now let's see whether are you able to tell the shortcut. So maybe we take a look over here. For question number 1, maybe can you tell me like, can you recognize, is it precipitation, neutralization, or under the rest? Okay, so for the equation number 1, what do you all think? Is it under precipitation? Which one? The what? No. As in, my question is, can you all decide, is there any shortcut or not? So the shortcut will be for neutralization, for precipitation, I shortcut precipitation, or the rest, which is no shortcut. So for this equation, do you think it falls under which category? 1, 2, or 3? You can point your fingers. Correct. Yeah, it's under number 3. Okay, so I write number 3, shortcut. Yeah, so this one, that means, sorry, this one no choice. You really need to do out step by step, cancel spectator ions to get the answer. Okay, so this one no shortcut. How about number 2? What do you all think? Number 2, which category is it under? Can tell? By the way, in case any of you lost, like why is it under number 3 is because this one, there's metal and acid. It's not acid and alkali. So not acid, alkali is not neutralization. Precipitation is starting 2 must be equals ma. This one already solid now, so cannot be precipitation now. So it's under the rest. So how equation 2, this one is equation number 2. Which one is it? 1, 2, or 3? Yes, correct. Yeah, right. Be confident. Yes, answer is 2. Precipitation. Why? You check solubility table. Remember STAN. STAN is always soluble, right? So this aqueous. This is aluminium chloride. You check your solubility table. Also aqueous. Then now you try lor. Could it be precipitation? Just try. So maybe it will become potassium salt partner, right? Instead of potassium with carbonate, now potassium with chloride. Then carbonate will be with aluminium. Then same thing, you go and check the solubility table. So you realize that, oh, this time round, potassium, SPAN, P. P is always aqueous. Then carbonate always follow the norm. They are usually insoluble. So yeah, you got aqueous get solid aqueous. So yeah, this is precipitation. So you use the precipitation shortcut. Focus on aluminium carbonate. Okay? I shall move on. Done copying, right? Okay, so moving on to question number 3. Can you tell me which equation do you think it falls under? Equation 3. Which one? So how got shortcut for number 3? Nobody knows. You do one by one lah. Is it neutralization? Neutralization is acid alkali, right? Is it acid alkali? No, right? Next, is it precipitation? Precipitation, I mentioned it must be aqueous, get solid aqueous, right? You look at the starting. Do you have aqueous or not? No, it's not aqueous, ma. So it's also not number 2, lor. So that means the answer is number 3. Okay, so this one no choice, have to write it out. Okay, then moving on to number 4. Number 4 should be easy. What's the answer? Number 1, because this is acid plus metal hydroxide. metal hydroxide, and then yeah, so this is under the category of base. So it's acid plus base. Then just write the answer. H plus OH get H2O. Then the last one, you're done copying, right? Okay, so moving on to equation number 5. Do you think is there any, like, which category is it under? 1, 2, or 3 for equation number 5? So how? Number 2. So in this case, number 2 is precipitation. Yeah, correct. Very good. Yep. Because this time around you check solubility table. SPAN. N is soluble. Then lithium. Oh, by the way, in case you're not sure what's lithium solubility, or you can check sulfate lah. All sulfates are soluble mah. So it's aqueous. Oh. And then aqueous, you try to get, you can get the solid aqueous. I leave it to you to figure out who is the solid so that you can write out the answer on your own. Okay? Yep, done. That's all. Okay lah, so since it's 7:05, I think I will end off the lesson here. So hope that you all managed to benefit from the session today and pick up some tips and tricks on like how to remember certain concepts. Just to share with you all is that if you all are like keen to like sign up for tuition in future, is that for like Sec 4 classes next year, we actually have like early bird sign up. So if you were to sign up like now, we actually give you like more perks. Then of course you want to wait for your exam result out. Then yeah, we also have a free trial session for you to try out to experience a real class before you confirm like whether you join your tuition or not. Yeah, so if you sign up with us in October, then we'll arrange for you to attend a free trial lesson in November. Then usually the group tuition will start depending on teacher. Some teachers start a bit earlier, some teachers start a bit later. Yep, so done. So maybe do you all mind helping to like give us a Google review if like you all appreciate the time that we spend to like, you know, arrange this like free lesson for you. Then can I appreciate a bit of your time to write a review in return? If you're very lazy, then maybe you can just put a 5-star then you submit lah. But of course, if can, maybe you can put some like text inside. Yeah. Or you want to comment about me, then yeah, my name is this. I'm Miss Felicia. Then after you all are done with the Google review, then I will show you the answer key QR code that you can use it to like finish up the work and then you can check your answer. Yeah. Okay, let me take out the QR code for the answer key. I will also be showing the physics answer key which I missed out giving just now. Yeah, thank you for the review. Yeah, so try to also join like follow Overmark on Instagram and Telegram. Yeah, so next time we have this kind of free lessons, yeah, we'll announce it on our like social media platforms. Yeah, then you can actually get up to date on all these like freebies. Okay, then so let me show you the answer key for the today's chemistry worksheet. This is the one, this is the chemistry one. Yep, so you'll scan to download the answer key for the chem one. Hold on, I'm going to flash out the physics one. So this is the chem answer key. Yep. So you can complete it. Yeah, take it as more practice lah before your exam. Okay, then wait. First, this one is the physics one. So physics one, I put it over here. Okay, does it work? Yep, so the right side one will be the physics answer key. For those of you who attended the physics class just now, sorry, I forgot to give the answer just now. Yep, so here's the answer key. Does it work? Or is it two corner? Should I shift it to the center? I think the Google review you're done scanning already, right? So I shift the physics answer key a bit more inside. Yep, like that. Okay lah, then done already. So after you are done like downloading all the answer key, yep, then you can pack and go already. Yep, so that's all for today. So there will be another round for bio at 7:30. Yep, so it's another Zoom login detail. So to log in, you just follow Overmark's Telegram O-level channel. Yeah, that's where the link will be posted. Yeah, so that's all for today. Hope you all managed to benefit from today. That's all. Bye-bye. And then feel free to go to the shelf there to take like some more notes. Then those of you who want physics IP notes, you can come to the front to collect it also. There's math outside, bio outside also. Yeah, you can take. No problem. Bye-bye. They're literally right outside.